My name is Gosia Śmieszek-Rice, and I'm Deputy Secretary of the Arctic Monitoring and Assessment Program, one of the working groups of the Arctic Council. And it is my great pleasure to welcome you to this session that is actually organized not by AMAP, but by Helen Finlay, who you can see on the screen. Helen is the senior oceanographer at Plymouth Marine Laboratory, and it's thanks to her that we are having this session here today. So, in the next hour, you are going to hear several presentations and discussion under the theme of navigating Arctic Ocean protection, current status and future directions. So, as many of you probably know here, the Arctic Ocean is not only the world's smallest ocean, but also the one that plays absolutely critical role in global ocean and climate systems. And today the Arctic Ocean is under increasing pressure from climate change, which results in sea ice loss, ocean acidification, warming and freshening that are occurring more rapidly in the region compared to the rest of the global ocean. So today in the event, we consider what is needed to protect these vulnerable ecosystems. In the session, we bring together a range of voices to discuss what roles different players have and how best to move science forward in order also to allow Indigenous and local communities to adapt to the changing conditions. At the same time, while raising critical considerations for mitigation and future sustainable uses of the Arctic Ocean. So, as the first speaker, it will be Helen herself with the latest science update about the Arctic Ocean. And a few words to say about Helen. Helen is interested, as mentioned, she is the senior biological oceanographer at Plymouth Marine Laboratory in the UK, and her interest encompasses understanding the effects of climate change and ocean acidification on marine ecosystems, and as well the application of this knowledge to maintain a healthy, sustainable ocean. So truly bringing science that we need for the action moving us forward. Helen, perhaps without further ado, if you can hear us, the floor is yours.
Thank you so much, and while I just share my screen, thank you again to you guys for hosting on our behalf without, as we weren't able to be there in person in the end, or I wasn't able to be there in person in the end. So I'm sorry not to be there, to be able to see you all in person. In fact, I'm looking at a blank screen, so hopefully you can hear me and see me okay, and now you can see my screen okay.
Everything is
so
correct.
Yeah, perfect. So I would like to just set the scene a little bit in terms of the latest science, so thinking about Arctic biospheric change. As mentioned, my interests include climate change, but also ocean acidification. So there's a little bit of bias towards ocean acidification in this talk. So I'm really going to touch on ocean acidification and how that's changing in the Arctic, but also thinking about ocean warming, and freshening and how that impacts circulation and things like, and other changes as well. So less talking about the sea ice, because I know there's lots of sessions about sea ice as well. And it may get touched on by some of the other speakers. So a lot of these updates come from these two reports. So the State of the Cryosphere report is led by the ICCI, who are hosting this Cryosphere Pavilion, and that came out last week. So I'd welcome people to have a look at that if you haven't already. And also the AMAP, so again, that came out late last year, earlier this year, which talks about the trends and impacts of changing climate. So first of all, ocean acidification. So how is the ocean changing in terms of carbonate chemistry? So just to make sure that everyone's on the same page, ocean acidification is where the carbon dioxide is taken up into the oceans from the atmosphere, and naturally over geological periods of time that carbon dioxide would react with seawater, it would become part of the marine carbonate system. But what we're doing is adding too much of that too quickly, and that's resulting in ocean acidification, which is causing the pH to decrease, and that's making the oceans become what we call more acidic. But it's also critically decreasing the amount of carbonate ions available in the ocean, which is causing the ocean to essentially kind of become what we can consider more corrosive to calcium carbonate minerals. So these two maps were generated from a recent publication we had on the ocean acidification planetary boundaries. The top map shows the change in acidity since the pre-industrial times to present day, so the percentage difference between those time periods. And the bottom map represents the aragonite saturation state, which is a measure of that calcium carbonate mineral corrosivity, if you like. So as the saturation state decreases, the ocean essentially becomes more corrosive to those minerals. And as you can see, the Arctic Ocean has seen, since pre-industrial times, an increase in acidity by about 40%, and a decrease in aragonite saturation state by over 30%. And these maps are really clear demonstrations that the Arctic region and Southern Ocean as well, but the Arctic is really one of the places that are being impacted most rapidly by ocean acidification. So why is that? Well, it's a complex situation. So many people have probably heard about Arctic amplification in terms of warming. The same sort of complex feedbacks, interactions occur for acidification as well. So the fact that you've got all these changes in cryosphere are actually impacting acidification. So if we think about open ocean system, then you get sea ice loss is actually driving an expanse of open water. That open water is then able to have increased gas exchange with the atmosphere. And also critically, things like wind-driven circulation are increasing, so we get more waves and wind across that ocean as it becomes open water rather than sea ice covered. And again, that can facilitate gas exchange. Also, critically, that loss of sea ice is affecting how the ocean circulates and mixing regimes, and so that changes the way the carbon is taken down from the surface to the deep ocean, but it also affects the way that nutrient dynamics work, and that can have knock-on consequences for biology and for how that affects ocean acidification as well. In a coastal fjord system, you also have the addition of things like glacial meltwater and sea ice meltwater, which can increase the fresh water added to the system, and that allows acidification to increase as well. And more recently, we've been recognizing the fact that thawing permafrost is actually increasing the organic carbon input into the oceans, and that organic carbon is remineralized back into CO2 as well. And so again, we've got an additional adding of carbon dioxide to the system and acidification. So those are really important. Acidification has consequences for organisms and ecosystems, and there's been more and more work showing that there are vulnerable species, particularly in the Arctic Ocean, ranging from the juvenile and early life stages of cod, both Atlantic and polar cod, northern shrimp species, crab and bivalves like scallops, and also these pteropods, which are these free-swimming snails, and they have been shown to have severe dissolution at levels of aragonite saturation state that is above what we would kind of consider the mineral dissolution of that shell. And this figure up at the top above this map here shows how severe those shells start to dissolve. And what we can do, Nina Bednasek and her team have actually mapped where we would expect pteropods to occur with that severe dissolution in the Arctic Ocean today. And you can see that 40 to 50% of the pteropods we would find in the Arctic Ocean, if they were in these regions, we would expect them to have severe dissolution. And so we can start to actually map where those impacts are happening. So moving on to ocean warming, recent ocean warming shows that the oceans generally have warmed incredibly rapidly over the last few years. The Arctic in particular, it's warmed at about 0.5 degrees per decade, and is continuing to warm at that rate, and that is a regional warming as well. So there's some areas of the Arctic that are warming faster and a few areas that are warming slower as well. And one of those areas that I just wanted to highlight is the Barents Sea. So this is what we consider, you've got warming of the ocean, but you've also got what we call Atlantification of the ocean. And that's where Atlantic water is moving up into the Arctic, and it's bringing in warmer, saltier water into the Arctic region. And these maps just represent how the sea surface temperature trends, so how quickly the ocean is warming in these areas. And you can see that even in the past 20 years, the ocean in this region has warmed by about 0.75 degrees per decade, and that warming trend is accelerating. And that's really important. The warming ocean has impacts on sea ice formation, so both winter sea ice retreat and also loss of summer sea ice is affected. If you've got a warmer ocean, it's more difficult to form sea ice. But also if you don't form sea ice, then you get different dynamics in terms of fresh water being formed as you melt that sea ice into the summer region. And that then has consequences again for things like how the ocean circulates, and also things like stratification, so how stratified the water is, what the temperature and salinity differences are between the surface and the deeper layers, and that affects mixing regimes as well. And so what we're seeing is a stronger mixing and more circulation dynamics changing in this region. And again, that's leading to ecosystem changes and ecosystem consequences to the point where we're starting to see shifts in phytoplankton, so at the bottom of the food web, but all the way up to fish species moving as well. And it's not just that long-term trend that's of concern. Actually, we're seeing an increase in intensity, duration, frequency, and extent of Arctic marine heat waves over the last 40 years or so. And this is just, this map here on the left is an example from the year 2023, which just shows a global map of marine heat waves. But what you can notice here are these really dark pixels in the Arctic Ocean, which is where extreme events have been seen. And that shows that really a lot of these marine heat waves are occurring in the polar regions, particularly the Arctic Ocean. And the map on the right here represents over longer time frames that the difference in sea surface temperature in these regions, so up to sort of 5-6 degrees warmer in these coastal regions during marine heatwave events. And so finally, I'm just going to touch on ocean circulation. So I've talked a little bit about the fact that ocean warming is having an impact on ocean circulation in terms of temperature differences, but actually we've seen an increase by about 13% in river discharge in the Arctic, which is bringing river water, fresh water into the Arctic system. And obviously we're seeing a lot of land ice melt, and that's also bringing fresh water into the Arctic Ocean as well. Just on a side note, that on a regional basis, the amount of the ice loss that is occurring on the land ice loss that is occurring in the Arctic is the biggest regional contributor to sea level rise for the whole globe. And so the Arctic land ice that we're losing is hugely important, not only for sea level rise, but actually also for how the ocean circulates and the amount of fresh water coming into that system as well. And so that has consequences for things like the overturning circulation, but also things like taking carbon away from the surface waters and how that sequesters carbon up to kind of nutrient dynamics and ecosystem response to that. And so if we're thinking about conservation, we really need to be thinking about all these changes as a backdrop to that conservation effort. And so in the Arctic Ocean, we've obviously got some conservation efforts going on, but I think it's really important to note that this is going to be continuing through the next kind of 50 to 100 years or so. Even if we were to stop emitting carbon dioxide tomorrow, the legacy impacts that we have from the carbon dioxide and greenhouse gases that have already gone to the atmosphere for the ocean are really important. The ocean is a much slower system, and those things will have a legacy impact for at least kind of the next 50 to 100 years, and we need to be taking those into consideration when we think about conservation in the Arctic region. So I'm going to finish there just to conclude. Thank you again for listening. The Arctic Ocean is continuing to acidify. Hopefully I've demonstrated why that's important for the Arctic Ocean, and that's impacting already today important key species for the Arctic food web, which has impacts for indigenous populations and local communities. The cryosphere is melting, so sea ice loss, land ice loss, and permafrost thaw all add to Arctic amplification of both warming and acidification, and things like sea level rise, as well as actually changing circulation patterns, which has knock-on consequences for ocean health and functioning and climate feedbacks. So again, just to highlight that while emissions reductions are absolutely necessary to drastically slow the pace of change, conservation efforts need to be climate smart to be able to be adaptive and resilient to these legacy impacts. So I'll leave it there and look forward to hearing the other talks and the discussion later on. Thank you very much.
Thank you very much, Helen. It was really excellent. Thank you for this overview. And if that's fine with you, there will be time for questions after all the presentations. And I think it will be very interesting to come back also to the conservation perspectives and how we can move forward on those. But before that, I would like to invite our second speaker here, Rolf Rödven, who is Executive Secretary of Arctic Monitoring and Assessment Program. I should know better the name of my own organization, AMAP. And Rolf will talk about the role of the Arctic Council and AMAP perspectives on the Arctic Ocean and Arctic conservation. Rolf, the floor is yours.
Thank you, Gosia, and I'm glad you remember the name of the organization, so the Arctic Monitoring and Assessment Program. But maybe we'll change to today, we can call it the Arctic Marine and Assessment Program. I'm going to talk a bit, I'm going to take up where Helen left, expand a bit about those challenges we see for the Arctic Ocean, and talk about how we can move forward with solutions particularly when it comes to monitoring and science policy processes. Next slide, please. So, as Helen already said, there's no place globally that warms faster than the Arctic. The Arctic warms 3 to 4 times as fast as any other place in the world. And that has cascading effects through the ecosystems. As she said, we have since 1978, 79 lost more than half of the sea ice covering the Arctic Ocean when we look on the minimum extent in September. That equals the area of India more or less, or more than India actually. And as we saw, it has tremendous effects on the exchange of carbon dioxide with oceans and ocean acidification. The wildfire is thawing rapidly, releasing both methane, as we saw, into the oceans, increasing ocean acidification, but also releasing mercury and metal mercury into the oceans, which is washed out to the rivers and taken up by organisms. Sorry, one slide back. We have wildfires raging, so like for instance in northeastern part of Arctic, in the Russian side, they have quadrupled since 2010, again releasing greenhouse gas emissions and pollutants to the oceans. And as Helen said, the Arctic oceans are acidifying 3 to 4 times as fast as any other ocean body in the world. And I think we can all sum it up by the graph you see on the right hand side. The Arctic is really not turning non-Arctic. It's going from a white Arctic to a green Arctic. So where we, before 2000, had about 1/3 of the year having temperatures above zero, we are now getting close to half of the year. And that really makes a change for the Arctic. It changes all the processes we see. And as I said last time, for those who don't believe that the water is in the form of ice or in the form of water, if that has any impact on you, try to cross a river on thin ice back where I live, and you realize it really makes a difference. Next slide, please. When it comes to contaminants, that's another thing that I addressed a bit, but there are more things to see. The Arctic, we thought of the Arctic as a pristine place, but all sea currents and all air currents leads up to the Arctic, bringing pollution from the lower latitudes, from the Asian side, from the European side, from the American side, up to the Arctic, where it falls down due to precipitation increasing when it's getting colder, being deposited on glaciers, but also being falling down in a marine environment and being taken up by organisms. And there's one common feature about both the contaminants, at least a lot of those concerning contaminants, and the creatures living in the Arctic, like myself. We do have an affinity for fat. It may not look like it, but we do. So, and that is the problem, because these contaminants, they stick to fat and they accumulate. So over time, the older you get, the higher concentrations of these contaminants are in your body. And please, back one slide. Could you please go back one slide? And also, moving from the lower parts of the food web to the higher parts of the food web, you have biomagnification. So that is that the top predator, like the orca here or polar bears or glacial gulls have a higher concentration than plankton or organisms on the lower side. Next slide, please. And we also see a huge change in the ecosystems and the biodiversity of the Arctic. Like, for instance, if you look on ivory gull, a beautiful little white gull, endemic to the Arctic, and this is the thing, although those species we have up there, they don't live anywhere else. They are endemic to the Arctic. The ivory gull, we've seen a population decline of 80 to 90% the last 20 years. This, of course, when the ice is disappearing, this is change in the sea ice algal communities. Seabirds in general have changed. And also fishes. You may think it's easy for a fish to migrate northwards, but if you're a bottom-dwelling fish and you are expelled from your habitat due to new invasive species, and you have to go from 50 meters depth to 3,000 meters depth, that makes a difference. That is not a livable habitat. So it's really, they can't move further north, and that is really of huge concern. Next slide, please. And also, climate change is the driver for a lot of these processes. For instance, when it comes to pollution, we have seen that after a long, steady decline, there's now an increase in, for instance, PCBs, one of the persistent organic pollutants in the Arctic, where pollutants being deposited on glaciers and ice now are mobilized again into the ecosystem. Mercury from permafrost, permafrost thaw, is released into rivers and washed out in the sea, taken up by organisms, biomagnified through the food chain, and causing issues. Next slide, please. So what we see in our assessment reports, this is the POPs report from 2021 and the Mercury report. We do see that several of the species, including, for instance, the polar bear on the slide on the left, there is an increase due to climate change in pollutants. Next slide, please. So how to move this into science policy? Well, actually, the Arctic has been a very successful when it comes to bringing Arctic data into policy processes, like, for instance, the Stockholm Convention and the Minamata Convention, but also the Paris Agreement was, a lot of those data underlying the Paris Agreement was based upon data from the Arctic Climate Impact Assessment Report in 2005 that laid the basis for the IPCC's work later. So the Arctic can really have an impact on conservation measures internationally. The question is, where do we go from now? But in any case, to be able to do such change, we need a good basis of data, which includes monitoring. Next slide, please. Next slide, please. So AMAP has, since the very beginning, monitoring all compartments of the Arctic in terms of contaminants, as you can see here, making sure that data is harmonized, that we monitor things in the same way, making sure that it's a throughout data, showing not only results from the Svalbard region, but we show the trends all over, because Arctic is not homogenic, and to be able to make sure that the data is reached on the does impact on the international stage, you have to show that it's more than just a local problem. So we've done it with contaminants. Next slide. We do it with air pollution, which of course then influence also the marine environment. Next slide, please. And last, what we started in 2019 with the first report in 2021 is when it comes to litter and microplastics, which is an issue of emerging concern. But there were no harmonized scheme. So when we started doing this, we harmonized our way of doing it with what other institutions like ICES and PICES does to make sure that it's done in the same way. And it's now taken over by IAEA to make sure that we can monitor how microplastics is taken up by organisms and it's going through the environment. Next slide, please. However, our picture is never complete. The polar bear do not care whether what it meets comes from climate change, invasive species, tourists and disturbance, hunting or pollutants. They have to face all these issues, and it's up to us to make sure that we, in a way, we both monitor and address these issues on the policy scene, is taking all of these issues into account in an integrative way. So we do not really, we can always mitigate one thing, but if that's not the right pressure, it does not have much effect. So we have to make sure that we do it in an integrative way. So next slide, please. And that's where I'm going to conclude. So thank you.
Thank you very much, Rolf. And I think it is true. Today we might be Arctic Marine, an assessment program that works just fine. So the next presentation. So we are hoping to have Pen Haddow with us online. However, due to the connectivity issues on his end, which are apparently caused by auroras in England, he might not be able to join us online, but we have a recording, so we are going to have the recording of his presentation. And before we go there, Pen in his presentation is going to talk about the conservation of the Central Arctic Ocean. And few words about him is that he is executive director of 90 North Foundation. And he's also explorer of the Arctic Ocean, now dedicated to advancing protection for the wildlife, biodiversity, and ecosystem services in the high seas region of the Central Arctic Ocean surrounding the North Pole. Pen in 2023 has been awarded the Shackleton Medal for protection of the polar region and has led numerous expeditions across the region. So he's going to share with us his views on this, and if we can pull out his presentation. Thank you.
Hello, I'm Pen Haddow, the director of the 90 North Foundation, which is a marine conservation body based in the United Kingdom. And we have a very particular area of interest which is known as the Central Arctic Ocean, which is the northernmost waters of our global ocean. In fact, the North Pole lies in the middle of it. Now, I've spent most of my working life since the 1980s working on the sea ice of the wider Arctic Ocean and the Central Arctic Ocean right at the top. I spent about 10,000 hours there in total, acting as a professional guide, making my own expeditions as a sort of solo project, and I've led international scientific research programs. All of those led me to realize that this sea ice cover that exists across the whole region is receding. It's becoming less and less during the summer times, and this is having some very significant impacts. And the 90 North Foundation is really all about protecting the biodiversity that has become dependent on the existence of sea ice. Many people think that the sea ice is just a geophysical phenomenon. It's just it's just stuff. Just a material, it's frozen seawater. But actually, while it is that, it is also a habitat that an enormous range of animals and plants have adapted to be able to exist in this very particular substance. So there are birds that fly above the sea ice, even right up to the North Pole itself, Ross's gulls and ivory gulls, for example. There are animals that live on the top surface of the sea ice. So of course everyone knows about the polar bears, and they use it as a hunting platform from which to hunt the seals that are living in the waters underneath the sea ice. And there are Arctic fox, which actually follow the tracks of the bears to find where the seals have been left behind, the kills, if you like, from the bears, and they feed on the remains of those seals as well. So you've got those animals living on the surface, and you've also then got walrus, and there are 6 species of seal that are ice dependent, that sometimes come up onto the ice for all sorts of different behavioural reasons. And then of course you've got the whales, various sorts of, well, there are 3 whales that are only found in the Arctic Ocean. There's the beluga whale, which is a white whale, known as sometimes by some as the sort of canary of the seas, because of its incredible vocal range, if you like, and the sophistication of its communications through the noises that it can make. There's the narwhal, which many of you will know, with its sort of long spiraled tooth coming through its upper lip. And there's the bowhead whale, which is the second heaviest whale on the planet. And they can live to sort of 240 odd years of age. Those three whales are only found in the Arctic Ocean. And then, of course, there is actually phytoplankton, tiny, tiny plants, and zooplankton, tiny, tiny animals that actually specialize in living inside the sea ice. The sea ice doesn't freeze as a sort of total solid. It has lots of little channels inside, a little bit like a honeycomb. And in those salty channels, all sorts of tiny life forms have adapted to survive and thrive in that environment. And then some of these, the phytoplankton, especially the plants, they live on the undersurface of the sea ice, especially in the summer times. The undersurface of the sea ice turns green with them being there. And then there are a whole raft of wildlife that lives in the water column under the world. And in fact, there are some areas within the Arctic Ocean that have warmed 7 times faster than the global average. So you can see that the effect of greenhouse gases on melting the sea ice is actually accelerating further warming because it's removing that protective heat shield. But something that many people don't realise is that this sea ice cover is also a habitat. It's literally an environment, if you like, that has a whole ecosystem, including wildlife, has evolved because of its existence. It's a habitat. So just as the sea ice has been shrinking, a habitat has been shrinking, putting more and more pressure on a range of species that have evolved specifically to inhabit above, on, in, or under the sea ice. So you can see there are stresses starting to come into the system in the central Arctic Ocean around the North Pole, both for the wildlife, for biodiversity, and therefore the ecosystem services that biodiversity provides globally, but also, as I said earlier, because it accelerates the warming process, because the cooling effect of that sea ice is being reduced and it's just being taken away, and just a plain ocean is being revealed that absorbs energy more readily. So what the 19 North Foundation is all about is finding ways to protect the biodiversity in this central Arctic Ocean region. It's got enough problems as it is, and what we want to do is make sure that it doesn't have to deal with additional impacts which produce stresses, which can then produce risks for individuals, for populations of specific species, and for the wider complex system, if you like, the entire ecosystem. And the only thing that's really going to change in terms of man-made interventions is that vessels can now access the region. That they might be vessels to do commercial fishing, because the sea ice isn't there anymore. I mean, throughout human history, hardly any vessels have ever gone into the central Arctic Ocean. They couldn't, unless they were icebreakers, and a very small number of those, even those, have ever been into the central Arctic Ocean. So, our work is about keeping out, they've never been in basically, and we want to make sure they never do go into the central Arctic Ocean. That's commercial fishing vessels, and there's a wonderful agreement that's already in place that needs to be kept in place, which is the Central Arctic Ocean Fisheries Agreement, brilliantly brought about by the Arctic Council. Then there's transboundary shipping, or sort of cargo shipping, if you like, for which, as the ice is removed, a much shorter route is created between, for example, Shanghai and Rotterdam in Europe. It's a much, much shorter route, and therefore it's a quicker route, and therefore it's a cheaper route, and so on. Now, there aren't probably going to be as many cargo vessels as many might imagine suddenly switching to this new route, because it's not for other reasons, it is not actually that commercial. But we want to make sure that transboundary, that shipping that's going really not just within its own country, but is going from one country through the Arctic Ocean, through the Central Arctic Ocean, and coming out to the other side. We want to make sure that never starts. And the third sort of activity that's vessel-based that we want to make sure never starts is deep-sea mining in the Central Arctic Ocean. So those are the three things. Fishing, which is already has got an excellent agreement in place, we just need to extend it. Shipping, which perhaps can be best dealt with through the International Maritime Organization, which is a UN body that is sort of responsible for global shipping. And then there's the deep sea mining. And there's another body that is tasked with protecting the environment when it comes to mining the seabed, and that's the International Seabed Authority. But of course, there's another agreement, a new treaty that's just come in. It was ratified in September, which is hugely exciting. 60 countries have ratified it, so it now enters into force this coming January 26. And this is the High Seas Treaty that's linked to an even bigger treaty, if you will, called the Convention on the Law of the Sea. And this High Seas Treaty enables, for the first time, the protection of biodiversity in areas that have been identified as being a particularly high risk. Now, what our argument would be is that the wildlife and the ecosystem and the biodiversity, if you like, within the Central Arctic Ocean is one of the most stressed areas of the global ocean, and is worthy of attention by the High Seas Treaty Secretariat that's currently being formed. So new is this treaty. So that is really what we're about, and I think, if you like, if you wanted to summarize our vision, it is that over the next 10 years or so, what either one single international agreement or a network of agreements from the different bodies combines to create what is in effect a North Pole marine reserve. That's the goal. That would be a marine reserve that is iconic. It includes the North Pole itself and that region at the top of our planet, and it would be for global public benefit. And it would be a statement that for everybody, men, women, children, worldwide, from every nation, that there is a real effort that is beginning to succeed in demonstrating that sustainability is the way forward, and that the authorities and the big international bodies understand the importance of what needs to be done to bring about global sustainability. So I look forward to the discussions later, if possible, if I can join you for those. But otherwise, thank you very much for listening, and I hope you have a really great experience at COP30. Thank you.
Excellent. And now we are going to move to our last but not least speaker, the Toste Tanua here from the Geomar Helmholtz Center from Ocean Research Kiel, and Toste is going to talk about the needs to sustainably observe the Arctic Ocean. And in this regard, I just wanted to mention a few things. I mean, Toste, you work as a senior scientist and a chemical oceanographer, but also you're particularly interested in improving the sustained ocean observation systems, and you are also leading the innovation platform, shaping an ocean of possibilities for science-industry collaboration that is enabling non-scientists to observe the ocean, which I think is something also that we can come back to in the questions. But before that, Toste, the floor is yours.
Okay, thank you very much. It's my pleasure to be here. And as we heard, I'm interested in ocean observations, and we're talking about the Arctic, we're talking about the ocean. I'm thinking about the ocean. Next slide, please. And my first comment here is that you cannot protect what you don't know, what you don't love, And to know it, we need the data. And the ocean is generally, next slide please. The ocean is generally a very difficult place to make observations. And the Arctic Ocean is a particularly difficult place to make observations. Yeah, let's see. Oh, there we go. So the previous speakers did a really good job in explaining why the Arctic Ocean is very important in terms of climate change. So I'm going to go very for these slides here. But this is a very recent slide from WMO State of the Climate Report that shows that we had the lowest sea ice extent ever measured in midwinter last year or this year. We see also shifts in phytoplankton functional communities here. So some phytoplankton are increasing and some are actually decreasing. Without going into some detail on these slides, these changes do affect the whole food chain. So that's big things and happens due to acidification and loss of sea ice. Next slide. This is what Helen is an expert on, ocean acidification. I just want to point out two things here. The lower graph talks about, the upper graph talks about pH, and pH is a logarithmic. A change from 7 to 8 will be a 10-fold increase, or from 8 to 7, a 10-fold decrease in acidification. And the lower one is about the saturation of aragonite, which is a calcium carbonate. And now Arctic Ocean is the only ocean that has a cover. The whole ocean is less than 1, which means that aragonite is dissolving. And Helen showed a nice picture of heptapods, and that is a very important species for the ecosystem in the Arctic. And they now have to fight against being dissolved in the water because it's acidic for them. So that's a big deal. And generally on the maps that Helen showed, you saw that the effect of acidification is much higher at high latitudes. And that has to do with temperature and salinity and the complicated carbonate system. But the Arctic is particularly sensitive to acidification. So that's a good place for Helen to work in. Next slide, please. And there are some other reasons to observe the Arctic. We see increased use of the Arctic, oil and gas, shipping routes. We heard the previous speakers talking about that. And also local communities. When you don't have sea ice, you get increased action on the shores and waves, things like that. So yeah, let's talk about the Global Ocean Observing System. So that is a system looking at how can we observe the global ocean in a sustainable way to deliver for climate, operational service, and ocean health. So GOOS is operating with many different tools, and if many users of a particular observing tool go together, we call it the network. Here I listed 5 of them that are relevant for the Arctic Ocean. It's GoShip repeat hydrography, so that is the kind of gold mark. Every 10 years we go across the Arctic Ocean or any ocean from north to south or across basins and make the best possible measurements in the full depth of the ocean. Anibos, very interesting, we put sensors on large marine animals. Ocean sites are long-term moorings. Argo floats are going up and down profiling, and there are technology now that we can actually handle that under sea ice. And GOA on is the Global Ocean Acidification Observing Network. Next slide, please. So how can we turn that into the Arctic? And GOOS has not been having a really regional alliance in the Arctic, and particular conditions in the Arctic. So a whole bunch of scientists from around the world has been working a few years now towards what we call a Arctic Ocean Regional Alliance, AORA. And you can see here some of the activities around AORA. But basically what it means is that we want to turn that more sporadic scientific expedition-like observations of the Arctic into a more long-term sustained to provide the baseline for protection and understanding the Arctic. Next slide, please. And here are some of the rationale, and you see data providers, we see data products, and we see data users. So we can talk more about the data providers. So there's going to be scientists, but there's also going to be others, actors in the ocean, in the Arctic that can provide these observations. We will have a formal representation within the Global Ocean Observing System. And it will be more overarching, sustained framework with better coordination between different actors with a long-term view of making sustained observations. Next slide, please. Another network is here, the DBO, Distributed Biological Observatory, and this is basically positions in the Arctic. And what this network says is that if you do an expedition to the Arctic and you come close to this area, do some particular observations. In that sense, we can build up time series, and time series are particularly important for understanding climate change. Next slide, please. And what I want to say in the last thing here is that holistic approach, integrated observations, make observations in a way that they can be used for many purposes and used by many actors, and not just focus. It's so difficult to get in the Arctic, in the high Arctic. So when you go there, make observations that can serve many purposes. So I'm going to stop there and looking forward to the discussion. Thank you.
Excellent, thank you. And perhaps I could already invite you to the stage, and Rolf as well, to the panel here. And I hope we can make it work. It will be, hopefully we can have Helen on the screen. So maybe I could invite two of you here. And I would sit here. And just to want to double check if we have Helen with us. Is there, yeah? Well, I think we're trying to reconnect with Helen, but perhaps I could start. So Tosta, perhaps the first question that I have to you, because it was so interesting to hear about the observation systems that you were talking about, but also specifically from your perspective, how can industry and community... Oh yeah, oh we have Helen with us. Hello Helen, can you hear us? Yep, perfect. All right, so coming back to my question to you, Tosta, about industry and communities coming together specifically in the Arctic Ocean, which is so difficult to access, how they can support long-term observations in the region. How do you see that?
So I think we have a huge opportunity with science-industry collaboration. And as I mentioned, there are more and more actors that can access the Arctic Ocean, the fisheries, cruise ships, commercial shippings. And we have an opportunity to put oceanographic sensors and sampling on these non-commercial vessels and infrastructure. The same goes actually for working with indigenous local populations in the Arctic. I think there's huge opportunities to engage what we call citizen science or community science. Okay, now it works again, maybe. Good. So this is what Shaping an Ocean of Possibility for Science-Industry Collaboration is all about. Enabling non-scientists to contribute to ocean observations, be it biodiversity, be it the carbon uptake, temperature, salinity. There's many different options. The ocean is so difficult to access, and there are a lot of non-scientific infrastructure out there that we can utilize. In particular in the Arctic, with a lot of stakeholders and right holders, to engage with them and have a communication on the requirements, the need, and together build an observing system, I think is critically important.
Thank you, and I just want to add in a bit there. As you mentioned, there are a lot of actors in moving into the Arctic, and one of them are the cruise industry, cruise ships, and we know that it's already. I mean, I had the pleasure of being on board Commodore Chocot this summer in the Arctic Ocean, and that vessel, which is the strongest ice-breaking vessel for NATO actually, has a scientific lab, and they have scientists on board all time. So you can apply to beta, and they do monitor. They do the more common monitoring, like the CTDs, like measuring salinity, temperature, and so on. And we know that there are initiatives on expanding that. And then we also have, if you go to the very other end of industries, like the local industries, from our side, we try to imply community-based monitoring, and that can also involve, like you say, like fishing vessels, small-scale fishing vessels, but also observations along the coastline of relevance and so on. However, whether you're on the more like the larger scale or the smaller scale side here, there is still a need for making sure that we observe things in the same way, to harmonize those observation programs and the way we measure things. Otherwise, and also to make sure that we observe and register and report the data in a way that makes them valid for scientific processes, in particular when it comes to science policy processes, because there's such strong requirements on the evidence there that we need to make sure that what we bring forward actually represents the situation. So it's a great potential, and with a little effort on how we do this, I think there's a lot we can do.
Yes, just comment on that. So yes, this standardization and harmonization is one of GOOS's main objectives, and having a strong GOOS regional alliance, or whatever we're going to call it in the end, is actually ensuring that we have this kind of comparability between the Arctic Ocean, North Atlantic, South Atlantic, Antarctic, and so on. Thanks.
Excellent, thank you. Another question that I had actually to you, Rolf, concerns the role of the Arctic Council working groups, and perhaps, of course, we can reflect on the role of AMAP, but also other working groups in shaping and supporting conservation in the Arctic. How, if you could comment on that?
Thank you. It's always good to be on home ground in that sense. For those that do not know the Arctic Council consists of 6 different working groups, and the strength of the system, or strength of the structure, it's kind of an ecosystem where you can it works in a modular way. You can add those modules you want and need to make sure that you bring forward the science and that you also bring forward action. So like, for instance, when it comes to contaminants, and one good example there is how we collaborate in a sequential way between AMAP and ACAP, the Arctic Contaminants Action Program, and EGBCM, the expert group on black carbon and methane, where AMAP bring forward the monitoring assessment and the results and recommendations, which are then taken up on the higher policy level by EGBCM, developing the aspirational targets when it comes to black carbon, but then also included in the way ACAP work, for instance, when it comes to imply or propose how to imply those on a local scale, like how can you do this locally to make sure that your emissions are decreased. And often that is it can be very simple, sometimes it can be more complicated. Also, I mean, we take it all the way from, I mean, when it comes to oceans, the Arctic Monitoring Assessment Program and our sister organization, Conservation of Arctic Flora and Fauna, we work very much on both the physical processes and the ecological processes, and that is taken on by PAIM, the Protection of Arctic Marine Environment, to policy making. They're more like a policy organ, working closely with IMO, for instance, to make sure that those recommendations are actually brought into the international policy scene. So that is one way we do that. And then, of course, we can add on the international layer and how we feed into that, but I guess that can come for a later discussion.
Thank you very much. And Helen, now turning to you, because it's, well, you cannot see, but I'm looking at you here. It's because one of your final points in the presentation was so clear that the impacts of climate change in the Arctic Ocean are not going away anytime soon, even if we halted emissions basically tomorrow. So from your perspective, what this legacy that we have in the region, what does it mean for the conservation efforts in the Arctic, and how we should be moving forward on those?
Thank you. Yes, hopefully you can hear me okay.
Very well, thank you.
Yep, great. So yeah, I think it's really important to make sure that when we're thinking about conservation, we're thinking about and planning moving forward that we're taking into account these climate change impacts. And the way we can kind of start to think about that is through climate smart marine protection and marine spatial planning, which is work that I know a number of different groups are doing, including colleagues here at PML. And that's where you take into account mapping and forward projections of climate change impacts in the system, as well as thinking about the social dynamics. Where are people going to be? What are their priorities? How can they move forward in terms of thinking about what's best for them in terms of adaptation, and then overlaying those kind of different aspects to think about where are the best places then to monitor and to protect parts of the regions that will allow species and ecosystems to thrive in spite of the fact that the climate is going to change. So there may be areas that are the hotspots for climate change, so they're really going to be impacted, and you're going to get species changes that will have consequences for the ecosystem as a whole and the services they provide to us. And so maybe they're the places that are maybe places that we need to put in place different management strategies to places that are potentially kind of climate change refugia, or areas that are less likely to be impacted and could benefit from being protected from these additional stresses of shipping and fishing and things like that. So I think it's really just taking into account when we start to plan, and I know people are already doing this, but just really being clear about the fact that this climate change, these impacts aren't going away, and the ocean has a really long memory, and it will take sort of hundreds of years really for a lot of these things to rebound, and so we need to just be considerate of that moving forward.
Thank you very much also for this point about the long memory of the ocean. And perhaps the final question that I have to all of you, if you could reflect on this, because as many might know about this, we are now preparing for the next International Polar Year. So 2032, 2043, of course, major effort that we are actually for the first time undertaking, not after 50 years, but after 25 years, because the changes that we see in the region, they are advancing so rapidly at such scale that it led us to realization that we cannot wait for 50 years for this campaign. So what are your thoughts ahead of the IPY? Perhaps how would you see advancing work on protection of the Arctic Ocean, observation, sustainable monitoring systems? How would you see our efforts toward the IPY and their realization there? And Tosta, perhaps we can start from you.
So, coming back to the observation and base and how we do these things, I wish that we could have a monitoring system in place with the new technology responding to the particular requirements and challenges of the Arctic, so we can design that. There are efforts like the Synoptic Arctic Survey, SIS, that are doing a lot of great work on trying to get icebreakers out there in a coordinated fashion, however that is possible. I think we can do much better and engaging then the private public partnership in ocean observations. I think that would be a major thing that I would like to push forward. Yeah.
Thank you. I think, just to follow up on you, like the integration of systems when it comes to observation, like how to exploit all those vessels, all those autonomous vehicles, remote sensing, as well as with transponders beaming across the ocean, like how to integrate all that data into a more complete understanding, and also, like I just talked about, to harmonize the observation systems in a way that we can kind of fill those gaps, which may not be visible from just one system, but when you compare them and you integrate them, you realize that there are gaps there and the potential we can really fill by actually interlinking those systems in a better way. Also, when it comes to the science and research itself, I think we have a lot to gain on interdisciplinary research, including also social sciences. In a way, as we spoke about earlier today, it's not one thing, it's the several things we need to address, and the several things we need to understand to make sure that we make this forward, and we are well beyond the time where there was one single researcher in one single discipline, where it was like the polar researcher. Now it's a community, it's an ecosystem of researchers, and you need to to task force them in a good way to make sure that you can address those challenges you want to address. And the last thing I would say, and this comes in the spirit of the Arctic Council, the international polar year is an international polar year. It's not a polar year with some Arctic states and some being left behind. It's not a polar year where it's just the Arctic, but it's the Arctic and Antarctica. And we need to make sure that we bring forward all our efforts, both when it comes to monitoring, when it comes to research, but I would say most important when it comes to how we bring science into policy making in a way that embraces all the actors, all the states in the common good. So thanks.
And Helen, turning to you.
Thank you. Yeah, I don't really know if I can top what Tosta and Wolf have said there. I totally agree with that in terms of international and interdisciplinary aspects. And I would hope that we can go beyond geopolitics to actually make that happen and have really nice funding opportunities to allow international researchers to come together to really make these things happen. And just like this COP is all supposed to be about implementation, we know enough. We know enough to know that we need to act now, and we know enough to be moving forward in this space. So we know we need observations, we know what those need to look like, we know we need to include social scientists, we need to include Indigenous communities. We need to bring all of those communities together to make actually these things fall into place, and so that this IPY can be not only about observing the system changing, but actually making sure that we can use those observations for keeping the ocean, and the Arctic Ocean in particular, but also the Southern Ocean, in a state that is healthy and functioning in a way that we in 25 years, 50 years down the line for the next IPY, we're actually seeing the curve bending the other way. That would be my wish for it. So thank you very much.
Thank you very much, Helen. I think those last words that yes, hopefully the IPY after the coming one, yeah, maybe we'll be looking at again at the 50-year mark for this one. And I think that's really a great place to conclude this session here. Once again, Helen, thank you so much for bringing us all together here. I think like Tosta said, it's true that when it comes to the Arctic Ocean, as so many things, well, we cannot protect what we don't understand, but at the same time, since this COP is the COP of action, we also know that or we know already enough to act. So perhaps we should be moving on two fronts in parallel. So thank you once again, especially to you, Helen, for bringing us all together, but also to Tosta, to Rolf, to Pen for his presentation, and everyone here. Thank you. Thank you, Helen. All right. We'll be taking off our headsets, so we'll not hear you anymore.
Good. All right, I'll log off now. So thank you very much.
Thank you again. Good night.
Yes, bye.